Understand foundation design and construction. Topic. Understand foundation design and construction. Today's objective. Identify the principles affecting the choice of foundations. Be able to explain the advantages and disadvantages affecting the choice of different foundations. Foundation design. Why do we need foundations? To transfer the load of a building safely to the ground below and avoid any settlement. Safe loading will be determined by calculation and by assessing the capability of the soil to carry load. Key term: safe loading. The solution calculated from the soil's ability to carry a load plus a safety factor. Foundation design. The function of any foundation is to safely sustain and transmit to the ground on which it rests the combined dead, imposed and wind loads in such a manner as not to cause any settlement or movement which would impair the stability or cause damage to any part of a building. The subsoil beneath the foundation is compressed and reacts by exerting an upward pressure to resist foundation loading. If the foundation load exceeds the maximum passive pressure of the ground, the bearing capacity, then a downward movement of the foundation could occur. There are two alternative remedies: increase the plan size of the foundation so as to reduce the load per unit area, reduce the loadings being carried by the foundations. Upward pressure to resist foundation loading. Foundation design. What could you do if the foundation load exceeds the bearing capacity of the ground? Increase the plan size of the foundation so as to reduce the load per unit area. Reduce the loadings being carried by the foundations. The function of any foundation is to safely sustain and transmit to the ground on which it rests the combined dead, imposed and wind loads in such a manner as not to cause any settlement or movement which would impair the stability or cause damage to any part of a building. The subsoil beneath the foundation is compressed and reacts by exerting an upward pressure to resist foundation loading. If the foundation load exceeds the maximum passive pressure of the ground, the bearing capacity, then a downward movement of the foundation could occur. There are two alternative remedies: increase the plan size of the foundation so as to reduce the load per unit area, reduce the loadings being carried by the foundations. Foundation design. In groups of 2/3 discuss the principles of design and factors that need to be considered in order to select the correct foundation. Bearing capacity of the soil, type of building, structure, contamination, cost, type of foundations, available, water table, loading, site constraints, external or site constraints, the physical size and shape of the site and whether it is possible or practicable to use mechanical digging equipment. Type of foundation. The type of building structure, how heavy the loads are that the building will carry or exert on the ground. The soil conditions, including whether the site is located in an area that has known problems such as radon gas, minerals or evidence of mineral extraction in the area. Ons available, whether the foundations are suitable for the type of building that is being designed. Foundation design. In groups of 2/3, how many different types of foundation can you list? Strip foundation, trench fill foundation, piled foundation, raft foundation, pad foundation. Foundation design. Traditional strip foundations. This is a well-established and proven method. Most builders are familiar with traditional strip foundations. Building services and pipes such as drains etc. will mostly cross the wall above the concrete, which will help in the construction works. Cheaper to create than trench fill for wider foundations that use more concrete. Foundation construction, strip foundations. Min. 150. Wall-tie foundation design. Trench fill foundations. Foundations are completed fairly quickly in the program, which means greater ground stability since earth is not left exposed. Reduced need for planking and strutting to form earthwork support, therefore considerable cost savings for the contractor. No need for operatives to work at the base of the trench and therefore is much safer, especially in poor ground conditions. Concrete usually stabilizes the earth with no risk of trenches collapsing and damaging blockwork. Concrete is strong enough to bridge minor soft spots in base of the trench or in poor bearing ground. Foundation design: raft foundation. Used where the soil has low load bearing capacity including loose sand, soft clays, filled material. Usually used where pad or strip foundations would cover more than 50% of the ground area below the building and hence becomes more economic to produce. Where differential movements are expected or where subsidence is likely due to mining or mineral extraction. Either flat slab of concrete or with edge beam thickening sections. Key term: raft foundation. A slab that supports the building over a large area. Foundation design: raft foundation advantages over strip foundation. No trenching required. Simple and quick to build. Less interference with subsoil water movement. No H&S risks regarding trenches. However, careful detailing to the edges to prevent cold bridging and frost attack. Designed on a one-off basis as no deemed to satisfy in the building regs. Key term: pad foundation. A mini raft similar in function to a raft but not connected to other pads that support structural members. Foundation design: piled foundations. Used where strip foundations or raft/slabs may not always be appropriate. Ground unsuitable for heavy load. Poor soil conditions. Economic/constructional considerations. Transmit the load of the building to the strata beyond the depth of spread foundations. The increased costs involved in the surplus excavation from foundation trenches is removed, resulting in cost savings. Smaller piling rigs and piling systems which have become available have made this an attractive option for smaller buildings. A series of piles then accepts a ring beam or tie beam to provide a flat, level surface on which to build. Foundation design: piled foundations. Main types of pile. Bearing piles transmit the building load directly to solid strata. Friction piles rely on shape and frictional resistance to the ground. They are used where safe bearing strata cannot be reached. Consolidated piles, used in situations where the ground is weak or waterlogged, the aim being to strengthen the overall nature of the ground rather than to provide specific point support. Sheet piles, used to contain earth and prevent movement that would result in a weakening of the natural foundation. They are more frequently used in temporary works but can be permanent. Foundation design: piled foundations. A series of piles then accepts a ring beam or tie beam to provide a flat, level surface on which to build. Foundation design: piled foundations. Draw and label. Foundation design: piled foundations. Piles can be made from steel, timber, very rarely used except on small projects such as piers, in situ or precast reinforced concrete. They are used either to transmit loads from the building through soft or compressible ground to firmer strata below, end-bearing pile, or to distribute loads into the subsoil along the length of the pile, friction pile. In housing, a concrete beam across the top of the piles distributes the load from the load-bearing brickwork into the piles themselves. Foundation design: piled foundations. There are a number of different piling systems. Replacement piles bore out the ground and then replace the void with concrete. A reinforcement cage is lowered into the wet concrete to resist any lateral forces in the ground which might fracture the pile, and to provide a connection for the ground beam which will support the walls. Displacement piles forced into the ground, pushing it out of the way as the piles are driven home. Foundation design. Complete worksheet 6.7.